And combinations, which we did last year, but I'm sure you guys forgot.
Yes.
Permutations. A permutation would be a situation like you guys are electing class officers like we did at the beginning of the year. And I don't know, what was there, like president, vice president. Let's just stick with those two. So, do you guys know how many kids are in your guys' class?
Like 20-something. 24.
I think
It's like 18. Yeah, I think we're at 20 or something.
It's like 18.
Just 18?
I think there's
No, there's
it's
more.
like 21.
Yeah.
Like 20, I want to say 21.
And then mine is barely, it's like 20.
Sorry, Jim.
Okay, anyways. I'm not gonna figure it out. So a permutation is for, like, out of all the kids in the class, how many different ways could we elect a president and a vice president? Now, does it matter who's the president and who's the vice president? Does the order matter there?
No.
Yes.
Ah.
Because there's a difference between president and vice president. So when the order matters, it's a permutation. So, do you guys remember the factorial thing? Yeah. Hold on. I'm on the wrong page.
So we're using the NPR ratio.
So, out of, well, what did we settle on, 18 or 20 kids, somewhere in there? We'll say 19, we'll split the difference. So, out of 19 kids, we have to choose 2. So you would write it as 19P2. The order matters with the permutation. So a different example would be if we're electing 2 students to student council. Okay, does the order matter there? Who's student council 1, student council 2? No. So in that case, that would be a combination. So order doesn't matter. Okay, do you know which one should have more permutations where the order does matter, or combinations where the order doesn't? Permutations should have more, because, you know, if Trey's president or Leo's vice president, or Leo's president, Trey's vice president, that would make a difference. But on combinations, it doesn't count any differently. So there's actually more permutations. So permutations are kind of simple. You do 19 factorial over, in this case, 19 minus 2 factorial. So 19 minus 2 factorial would be 17 factorial, right? So if we had to do this without a calculator, it'd actually be pretty easy, but, right. 19, remember, factorial means like 19 times 18 times 17, dot, dot, dot. This is 17 times 16, dot, dot, dot. So the 17 times whatever cancels out, it's just 19 times 18. It's kind of like, we've kind of done this before, but in the president spot, how many possibilities are there? 19. In the vice president spot, how many possibilities are there? 18. So that's kind of like what we've done in the past. But anyways, so combinations, the order doesn't matter, and you have to divide by more stuff. So it kind of looks the same. It starts off the same, but then you have to add on, the factorial of whatever this number is. So that's what it looks like. Anyways, that's how it's gonna go. All right. So the main tricky part is figuring out whether the order matters or not. It's kind of easy one today. Go back to the book tomorrow.
Oh.
Much years and much suffering.
Great problems. Okay.
Are you guys thinking like Whitley? She's a sophomore. There are 20?
There's 20, I think there's like 26.
I'm not paying attention in this class.
Okay, there's 20.
Here you go. I think it starts mostly on this page somewhere. Maybe, no, not there. Starts here. Yeah.
Okay. So on number 1, it would be 7 factorial over 7 minus 6 factorial. Factorial. Well, 7 minus 6 factorial is 1 factorial, which is like 1. So it's just 7 factorial basically. It's a big number, I don't know what that is. 5 what?
5040.
Yeah, sounds familiar. Okay. Okay. I know these buttons are in your calculator, but for now, on 1 through 8, I want you to go ahead and write this part down too. Cry me a river. Alright, number 3. So 3 would be 6 factorial over 6 minus 3 factorial. So 6 factorial over 3 factorial, the 3 factorial would cancel out, so it'd just be like 6 times 5 times 4. Numero 5. Okay, 5, it changes to combinations. So instead of just 24 factorial over 24 minus 3 factorial, we're going to add on a 3 factorial. So this would be 21 factorial, which would take away everything below 22. And 3 factorial is like 6. Whatever that is. Yeah, like 80 times 20. That's too much for my little brain. Number 7, 14. 7, 24. 20, 24. Okay, 14.
Hey, that's this week.
14 minus 6, 6. Okay, this would be 8 factorial, so that would eliminate everything below 9. And then 6 factorial is like 720. Anyway, you don't have to write that part, but
Yeah.
that's kind of how I think about it.
My calculator keeps saying syntax error whenever I plug that in.
Well, maybe once it multiplies between that. Sure it didn't multiply.
Yeah, that worked.
What'd it come out to?
1513520.
That's wrong.
That's too
Yeah.
big.
It's
3003.
Say again?
3003.
3003. Too big. And also, you can use your special buttons on the calculator, I don't care. You remember where the combination button on the calculator was?
No.
It should say
It's in one of the menus.
NPR or NCR.
Yeah. Below the delete and clear button.
Yeah. Delete button is. It is found. Okay, so on number 9, I'll be a little bit nicer. The only thing you really need to show is like 7p6 or 24c3, that kind of thing. That'll be enough. So we need to figure out, is it a permutation or combination? So on permutation, does the order matter or not? Yes, it does. Somehow you have to get that in your brains. I don't know. I haven't really thought of a trick for you though. So permutation order matters. So the student body of, look at this, almost the exact same thing I said, of 20 students wants to elect president, vice president, secretary, and treasurer. So does the order matter?
Yes.
Yes, because those positions are different. So we're going to use P for permutation. So out of the 20 students, permutation of 4 students. I'm not sure what the correct way of saying that is. 20 permutation 4. Or I think sometimes I say permutation 20 choosing 4, something like that. But anyway, that's all you do. So on 11, a 13 field hockey players need to choose a captain and co-captain. Does the order matter on that? Yeah, they gave them different titles, so I'm going to say, yeah, those are different things. So 13 choosing 2. 13, selecting which 7 players will be in batting order on a 10-person team.
So that doesn't see your combination.
Yeah. But, yeah, batting order kind of matters, but. I don't know. You guys play baseball? Anybody?
No.
Softball?
You had a season. I was second baseman freshman year. I went crazy.
I used to be shortstop when I was like in elementary.
Didn't you play for like 2 weeks?
Yeah, I only played 2 games.
And then quit.
Okay, yeah, they said the
I
order
didn't quit,
doesn't
they just
matter.
needed me because they didn't have enough people. And once I got more people,
You just did go.
yeah, ball never killed me in 2 games.
Okay, how's there only 7 people in the batting order? I don't know. Okay, we'll just,
So do we have to solve these?
yeah, you do need to plug those in. Okay, number 15, you're setting the combination on a 5-digit lock. You want to use the numbers 3, 8, 1, 7, 5, but don't care what order they're in.
Combination.
So is it 5 combination 5? Or 5C5?
They're only equal in combination.
Yeah, that would only be one thing.
What about,
1. 5 combination 5.
do you have
That's
25? No, that's what I just
Okay,
said.
they are saying that the order matters on this one.
It just says you don't lie.
I know, but it. So they're saying we're definitely using those 5 digits,
But
But-
there's different orders to that.
but if you put them in different order, it does make a different combination. So anyway, they said permutation. It's a confusing one.
I would have told you.
Yeah, that one I feel like is just 5 factorial. It would be written as a permutation.
5P5. 5P5.
Oh, oh yeah, 5p5 does make 5 factorial. doesn't it? Yeah. Okay. Yeah, I wouldn't even call that a permutation, but okay. Number 17, the student body, yeah, that does equal 120. The student body of 50 students wants to elect 4 representatives. Does the order matter on 4 representatives? No, they're all the same position. So that would be a combination, so 50 choosing 4. Number 19, student body of 10 students wants, okay, it's a repeat. By this time, it's out of 10. They want to elect president, vice president, secretary, treasurer. So that's a permutation. 10, choosing 4.
I think you're getting the hang of this now.
Okay, 21, there are 200 athletes at a meeting. They each shake hands with everyone else. It's a lot of germs. How many handshakes were there? Ooh, it's different.
Is that 200 C 200?
Just for the one.
Yeah, if you're counting how many handshakes, yeah, that would be combination. Doesn't matter what order you shake people's hands. 200, yeah. Wait, that would just be one. I can't hear it.
You do 200 back for it.
Wow.
Well, the way I would think of it is the first person would shake 199 hands. Second person would shake 198 hands, because you already counted one of his shakes. So it'd be like that.
Oh.
But that's not a combination, combination.
Would you do 200 C 100?
Why would it be 100?
Because then you'd have two people who would shake their hands and then you'd be done and you'd go to another one. Would it happen?
No, well, that doesn't make sense on. That is the right answer. I don't know how you get it from a combination though. I don't know. We'll skip that one. Good way to think about it. This is a trick I learned once upon a time when you're adding series of numbers. If you add the first and last together, that's the same as adding like the second and second to last. Like 199 plus 1 is the same as 198 plus 2, same as 197 plus 3. And the number of combos is like these divided by 2. 199 numbers divided by 2. Anyway, that gives you the answer, but I don't know how they got it from a combination, to be honest. Let's think about that for a minute. Okay, 23, I'll come back to it. A group of 25 people are going to... No, okay. A group of 25 people are going to run a race. The top 5 finishers advance to the finals. So does the order matter if they're talking about 5 people get to go on to the finals?
No.
No. So that would be combination, 25, choosing 5. Okay. Number 25, Julio and Scott are planning trips to 4 countries this year. There are 7 countries they would like to visit. They're deciding which countries to skip. Okay, does it matter what order they choose the countries?
No.
No. Like if they go to Italy or France, France or Italy, that doesn't really matter. So it's a combination. So it's 7 choosing 4. 27, there are 50 students at a meeting. They each shake hands with every, oh, here it is again.
Skip this one too.
It would be 51 times, no, it would be 50 times 49 over 2. No, oh, yeah, that's right. Whatever that is. Okay, 27, 29. A group of, yeah, I'll come back to it, see what I'm figuring out. A group of 25 people are going to run a race. The 3 top runners earn gold, silver, bronze. Does the order matter, gold, silver, bronze?
Yes.
So that's a permutation. Uh-oh. Somebody broke it.
Is like that too, Mr. Jordan.
The handshakes.
Yeah.
Okay.
So it's
3
24.
handshake problem.
No, 24 too.
Also,
24 is kind of
10's
a
kind of
handshake
short.
problem. It's not a handshake problem, but it's.
The same.
Which one?
10 and 24.
26 yeah.
Should we just not do it with those
They each give a Valentine's card. How many cards were given? Well, that would just be like 259 times 260. Because every politician would give out 259 Valentine's cards.
Okay.
Assuming they're not giving one to themselves, right?
so is that what you want to split 259 times 260?
Boom.
Yeah, that's fine.
Okay.
Is this it? That's the wrong one.
Yeah, that's definitely the wrong one.
Okay, whatever. Whatever.
Finally
Wait,
got
so
a
what do we
wood
do on
project.
10, Mr. Jordan? Is it?
Got a wood project.
Yeah.
Okay, so how much would a it's not the handshake one. How many Valentine's Day cards would one politician give out?
259. Oh,
Right.
which one are we on?
Yeah. And would the second politician give out 259? Yes. So it's 259 times 260. Yeah.
260.
Yeah. Sometimes, yeah, I'm having trouble figuring out how they want us to use combinations with some of these. The handshakes mostly, but also with some.
We didn't do 27,
Finding
right?
good wood so I can use old fence.
27 is handshake. So 29, a group of 25 people are going. Oh, we already talked about that one.
I think it's like one wood fence post.
Yeah, I was just asking if you did 20.
Yeah, it's 25 choosing 4.
Exactly.
Wait.
29 is a permutation because gold, silver. Oh, no, sorry, it's 30. Gold, silver, bronze.
On 22, it's the same problem as like,
Batting order for 10 players on 11-person team. So that would be,
wouldn't it be 10 combinations?
yeah, they said the order doesn't matter. I find that kind of debatable, but yeah, they use combination. So it's 11, combination 11 choosing.
That only
10.
comes up to 11. That just seems very weird.
Is that a really low number for that?
Yeah, because
You only have one to change.
if the order doesn't matter, yeah, there's only one extra guy you could bring in and sub out. So there's not a lot of possibilities. Okay. Hmm?
How is like, on 26, Trey has 5P5, but it says, but you don't care what order they are in, so how is that not combination?
Just-
Yeah.
Just
yeah.
look at the other lock. problem.
Yeah,
It's
Yeah,
be-
well, how is that one not?
okay. Yeah, it says you don't care what order they're in, but when you put them in a different order, it does change the combination.
Okay.
So in other words, you're not choosing it to be in that order. You just want any combination of those numbers. So the order is gonna matter. I know, it's weird. The way they said it made it confusing, but
Agreed.